In this video, I'm going to talk about geometric probability distribution. First, let's take a look at what is a geometric probability distribution. It's a probability distribution for a discrete random variable x with probability p of x such that all criteria for binomial probability distribution exist except the number of trials n is not a fixed number. A trial is repeated until a success occurs on the x trial, where x is greater than or equal to 1. The repeated trials are independent of each other. The probability of success p remains the same for each trial where p is a number between 0 and 1 inclusive. The probability distribution for each outcome has to be between 0 and 1 inclusive. And the sum of all probabilities is always equal to 1. How to find the probability of a geometric probability distribution? The probability that the first success will occur on trial number x is given by p times q to the power x minus 1, where q is 1 minus p, and p was probability of success per attempt. The mean will be 1 over p, mu. The variance will be q divided by p squared, sigma squared. And a standard deviation, sigma, is always the square root of the variance, sigma squared. Consider a geometric probability distribution for a discrete random variable x with probability of success p equal to 0.2. We want to find q. We want to find probability that x is equal to 2, meaning that the first success happens on a second trial. We want to find probability that x is less than or equal to 2, meaning that the first success could happen on a second trial or on the first trial. We want to find the mean, mu, the variance, sigma squared, and a standard deviation, sigma. To find q, we're going to use the formula 1 minus p. P was 0.2, so q will be 0.8. To find a probability that the first success happens on a second trial, we're going to use the formula, and we get 0.16. To find a probability that x is less than or equal to 2, meaning the first success happens on a second trial or prior to that on the first trial, we're going to find probability that x is 2 plus probability that x is 1, and the answer for that is 0.36. To find the mean, mu, we use the formula 1 over p. We plug in the numbers, and the mean is 5. For the variance, sigma squared, we're going to use the formula q divided by p squared, plug in the numbers, and we get 20. And for the standard deviation, sigma, we're going to take a square root of the variance. So square root of 20 is approximately 4.5. Now, how to find geometric probability distribution using TI? If you have probability that x is equal to a, you use GeoMet PDF. If you have probability that x is less than or equal to a, you use GeoMet CDF. If you have probability that x is greater than or equal to a, we're going to use the complement rule, 1 minus GeoMet CDF, but you reduce the a by 1, so you get a minus 1. And if you want to find probability that x falls between two numbers inclusive, then we use GeoMet CDF twice. And it was the same style when we did binomial probability distribution. To find the TI commands GeoMet PDF and GeoMet CDF, you press second, vars, and you arrow down until you locate GeoMet PDF and GeoMet CDF. A certain basketball player in NBA makes 70% of his free throws. What's the probability that he misses his first two free throws and makes the third one? What's the probability that he makes his first or second free throws? What's the probability that he makes his first free throw after the fourth attempt? So this problem fits all criteria of a geometric probability distribution where probability of success is 0.7 per attempt and probability of failure is Q equal to 0.3 per attempt. Let X be the number of free throws when he makes his first success. Now, to find probability that he misses his first two free throws and makes the third one, we need to find probability that the first success happens on a third trial, x equal to 3. For that, we're going to use GeoMet PDF, and the answer is 0.063. To find a probability that he makes his first or second free throws, we want x to be less than or equal to 2. For that, we can use GeoMet CDF, and the answer for that is 0.91. To find a probability that he makes his first free throw after the fourth attempt, this basically means that we need to find probability that x is greater than 4. If x is greater than 4, then x has to be greater than or equal to 5. Here, we're going to use the complement rule. We're going to take away probability that x is less than or equal to 4 from total probability 1. And that would be 1 minus GeoMet CDF. And the answer for that is 0.0081. I hope this presentation helped you understand geometric probability distribution.